Common Core Math Practice 3 by Dr. Leslie Suiters. Construct viable arguments and critique the reasoning of others. For the first portion of this practice, constructing viable arguments, students need to be able to consider the context, use examples and non-examples, and use models such as objects, drawings, and diagrams and actions to explain their work. To critique the reasoning of others, they need to be good listeners, to compare arguments, identify flawed logic, and ask questions to clarify or improve arguments. Okay, let's unpack the standard. Would we be satisfied as teachers if students gave us the correct answer but weren't able to explain how they got it or prove the answer makes sense? Students should be able to justify their answers, share reasoning, defend their process for finding the answer, and assess other students' thinking and disagree or agree with them, and be able to clearly communicate their understanding and agreement or disagreement with others. To understand what students are explaining to you and ways that they might explain things to you, you need to know the difference between assertions and arguments. Assertions are when students say that they got an answer right because it is, or because I followed the steps. They often will state a belief without being able to support it with reasoning. Arguments, on the other hand, challenge students to back up an answer with facts, data, mathematical reasons, and it helps them think about the math and can lead them to discover mistakes as well as insights. Here's an example of some dialogue that it can occur during discussion. Mrs. Davis, who's a 6th grade teacher, asked her students to find the product of 3 3/10 and 28 4500. The class shared responses ranging from 9,388 5/10, 93 885 thousandths, and 93,885. The teacher began with stating, "We have quite a few possibilities. Which do you think is accurate?" Andrew said, "I think 9,388 5/10. I just multiplied the numbers and moved the decimal place 3 spots." That's the shortcut for multiplying decimals. Who agrees with Andrew with this response, 9,388 5/10? A few hands raised. The teacher said, "Are there any other ideas?" Melissa said, "I just did multiplication, but then I couldn't remember which way to move the decimal. So I figured that 3 3/10 was about 3. And I'll write that down. About 3. And 28 4500 was about 30. And the teacher said, "Why did you change the numbers?" Melissa said, 3 and 30 are easy to multiply. I used easy numbers. Mrs. Davis asked Melissa to record her thinking on the board before continuing. Melissa wrote the initial expression and her version with easier numbers. So 3 times 30 is 90. And so I knew my answer had to be close to 90. When I looked at my product, 93885, I knew that the decimal point had to be between the 3 and 8. The product is 93 885 thousandths. This answer right here, because that is close to 90. And then teacher said, how many people couldn't remember which way to move the decimal point? And close to half of the class raised their hands. So this just gives an example of how understanding the concepts and being able to explain it in their own words can help them rationalize and make sense of problems. Students also have to have language skills to construct strong arguments. They have to actively listen to their classmates' thinking, evaluate their arguments, make decisions as to whether they agree or disagree with their points. And how can we refine student skills? We need to ask students to use concrete materials, use diagrams, use specific grade-appropriate vocabulary, and use math definitions. We also need to ask questions such as, does that make sense? And why is that true? Give opportunities for students to explain their arguments. There are 3 suggested classroom test aid techniques to help students improve constructing arguments and critiquing with using reasoning. And I'll explain eliminate it, agree or disagree, and my 2 cents. Eliminate it is when you provide 4 math concepts and ask students to decide which one should be eliminated. In this case, an example is a student suggested that they would eliminate the word join because add, subtract, and multiply are operations. The teacher may say, does that make sense? And the student would say, I would eliminate subtract, because when you add or multiply, you join things. And then the teacher says, which one do you agree with, the join or subtract? And in a lot of cases, as long as the students can justify their reasoning, then that's acceptable. Here's another example of an eliminated task. Okay, so Beth, which you had the numbers 8, 2, 5, and 10. And tell us which number you picked that does not fit and why.
I chose number 5 because it does not. Because 8, 2, and 10 are all multiples of 2, and 5 is not a multiple of 2, it's a multiple of 1.
Okay. All right. I can
Nothing plus 2 equals 5. Where nothing times 2 or something like that.
Okay. Will, would you add anything to what Beth said about hers? Or does it make sense?
No, I think it makes sense.
Okay. All right, so Will, what number did you pick?
I choose number 8 because everything because like 2 times 5 equals 10, 5 times 2 equals 10, and 1 times 10 equals 10, and those all are 10 is all of the multiples of those numbers, but 8 isn't. Nothing times 8 is 10.
Okay. Beth, do you agree or would you add anything to that?
I don't really know what to add to it, but I agree with it. I think both of our answers are right because both of our answers make sense. So I think both of our answers are correct, even though they're not the same.
Okay, thank you. Agree or disagree is a strategy where a teacher poses a math statement, asking students to agree or disagree with the statement. Students must include math data or reasoning to support their decision. An example of agree or disagree is a situation where you ask students to tell you why they think 5 nickels are worth more than 3 dimes, if they agree or disagree. One student said, I disagree because a dime is worth 10 cents, and there are 3. 10 plus 10 plus 10 equals 30. Nickels are worth 5 cents, and there are 5 nickels. 5 plus 5 plus 5 plus 5 plus 5, 1, 2, 3, 4, 5, equals 25. And 25 cents is less than, 30 cents. My 2 cents is a strategy where students review the arguments of others in advising or expand upon their ideas. The teacher provides sample arguments with flawed or incomplete logic. Students see that there are different approaches to saying the same thing. Students can also be challenged to create their own flawed arguments for others to critique. Questions that teachers might ask for this strategy is, what should we keep and why? What should we delete and why? And what should we add? How does that improve the argument? Be sure to download the Math Practice 3 handout from the wiki after you've watched this video and respond to the questions before class so that you will be prepared.